In this video, we will introduce the features of various isolators, an indispensable component for analog signal interfaces, and how to select the appropriate one for each application. DC signal isolators, or isolators, are widely used in industrial process instruments, various measuring instruments, IT-related equipment, and medical equipment. This block diagram shows a simple explanation of how an isolator operates. While signals to the input section are transmitted directly to the output section, the input and output sections are separated galvanically from each other. Even if there is a potential difference between the input and output sections, no current flows between the sections. Therefore, the transmitted signal is not affected. By using an isolator, ground loops can be prevented. For example, if both of the two instruments connected in series are grounded, the downstream instrument is bypassed. Isolators can prevent this. Signal noise effects can be prevented. For example, signal noise effects can be caused by an imbalance in the ground potential of the receiving instrument. Isolators can prevent this. Equipment can be protected from damage. For example, strong transient voltage surges caused by electromagnetic waves from large power sources or magnetic motor starters can be induced in the equipment. Isolators can prevent this. We also have a video showing the effectiveness of the above three aspects of isolators as verified by experiments. Please take a look. Using isolation can protect equipment from malfunction or damage and prevent risks of electric shock to humans. Furthermore, by passing signals between devices from different vendors via an isolator, the boundary point of responsibility can be made clear even when a system failure occurs. M-System offers various types of isolators. The products can be broadly classified into two types: 4-wire types that require an external power source and 2-wire types that do not. Furthermore, 4-wire type isolators are available in single output and dual output types. The most common type of isolator is the 4-wire standard response time single output signal transmitter. Here, we will introduce some other products with special features such as dual output isolators, input loop powered isolators, output loop powered isolators, high-speed and ultra-high-speed response isolators, current loop supplies for dual use as isolators, and HART isolators. These will be discussed with notes on specification selection and usage. First, we will look at dual output isolators. When you want to branch field signals from an existing control loop and use them for another purpose, a dual output isolator can be used. This way, even if a wire break or other problem occurs somewhere in the newly branched loop, the impact can be limited to the branched loop, making troubleshooting easier and providing peace of mind. Next, we will examine input loop powered isolators and output loop powered isolators. An input loop-powered isolator is a signal conditioner designed to take the power supply to drive the switching circuit from the 4 mA portion of the input signal 4 to 20 mA DC. This is a block diagram of an input loop-powered isolator. By switching the isolation transformer, the signal is passed to the secondary side. There are no circuits on the secondary side that require a power supply. Since no power source is required, it can be used simply by wiring the input and output signals. It also operates with significantly less power than a typical line-powered isolator and generates almost no internal heat. However, since the loop power is limited, the allowable load resistance is about half that of a line-powered isolator. Input loop-powered isolators need only 2 input terminals and 2 output terminals per channel, for a total of 4 terminals, so a single unit like this product normally contains 2 channels. Even if unexpected problems occur during the installation of new or additional equipment, input loop-powered isolators are ideal for retrofitting because they do not require power supply or panel space. In contrast to 2-wire isolators that take drive power from the input signal loop, there are also isolators that take drive power from the output signal loop. They are similar in that they do not require wiring for a power supply. This is a block diagram of an output loop-powered isolator. In addition to the isolation transformer for I/O signal isolation, another isolation transformer is used to supply power from the secondary side to the primary side. The 2-wire type is often used when there is no power supply for the isolator at the installation site, and the signal transmission distance is long, as they can reduce costs. Next is high-speed and ultra-high-speed response isolators. M-System offers 3 major ranges of response time for isolators. For the 90% response time of a step input, standard types are about 0.3 to 0.5 seconds. High-speed types are 1 to 25 milliseconds. And ultra-high-speed types are 30 to 500 microseconds. For applications that handle periodically varying input signals, such as vibration analysis, the frequency characteristics should also be considered. The value listed as the frequency characteristics is the frequency at which the output amplitude is -3 decibels, or approximately 0.7 times the output amplitude, when a sine wave is input to the isolator and the frequency is increased. A higher value for the frequency characteristics indicates a better response to higher frequencies. Care should be taken when selecting fast response time isolators. The input wiring of an isolator that passes near a motor, large transformer, or other device that generates electromagnetic fields will be affected by commercial frequency noise, etc., due to electromagnetic induction in the wiring. The input circuit of standard type isolators incorporates a filter circuit to eliminate this noise, but the filter circuit cannot be used for high-speed and ultra-high-speed types because of their response times. Therefore, care must be taken in the wiring method to prevent exposure to noise. keeping a distance from high voltage, high current wiring, using a conduit tube, and using shielded twisted pair cables, etc., are effective countermeasures. Fast response time does not necessarily mean superior performance. It is important to select a response time appropriate for each application, ranging from protecting relatively low-speed process instruments from damage to vibration analysis equipment that requires ultra-high-speed input signal processing. Next, we will look at current loop supplies for dual use as isolators. For current loop supplies that provide 24-volt DC power to two-wire transmitters, such as flow meters and level transmitters, there are products that can also be used as isolators by changing the wiring without using sensor excitation. This is useful for cases such as when you don't know whether a field instrument is a two-wire or four-wire type, but want to arrange for an in-panel instrument ahead of time. Finally, there are HART isolators. Recently, many field instruments, such as differential pressure transmitters, are equipped with HART communication functions as standard. HART isolators have the function of isolating and passing through the 4 to 20 mA DC output signals of field instruments and the HART digital signal superimposed on it, respectively. With HART isolators, HART signals can be read anywhere in the input and output loops. Isolators are an indispensable component for analog signal interfaces. M-System offers over 200 models of isolators, from plug-in types to onboard isolation amplifiers. Standard production lead time for major products is 3 to 4 days, and we can also respond to customer emergencies with our same-day production system called the Quick Service Center. Our track record of shipping approximately 150,000 isolators per year and a cumulative total of 3.64 million units is proof of our reliability. We would like to recommend M-System's isolators.
Thank you for watching.